This is lesson 4.5, writing a function rule. Your objective is to write equations that represent functions. Many real-world functional relationships can be represented by equations. You can use an equation to find the solution of a given real-world problem. For example, you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? First, you need to break down the problem and figure out what the relationship is. The temperature is 40 degrees more than 1/4 of the number of chirps that the snowy tree cricket makes in 1 minute. Once you've figured out what the relationship is, then we can start to define our variables. So instead of writing temperature, we could say, well, let the variable t equal temperature, and let n equal the number of chirps in 1 minute. Once you've defined your variables, you can replace them into your sentence and start creating your equation. So we can say, well, the temperature is equal to 40 more than, so plus, 1/4 of, meaning multiply, the number of chirps in a minute. So now you can say that the function rule that represents the situation is t equals 40 plus 1/4 n. We can also write a nonlinear function rule. So write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9 feet? So this is 2 steps. First, we need to write the function rule. Then we need to actually figure out the area for a given width. So the first thing you need to do is figure out the general relationship first. So we know that the area of a rectangle is the product of its length and its width. So we can write our formula A equals L times W. But we're also given some more information. We're given that the length is 5 feet more than its width. So we need to revise the model to show that the length is 5 feet more than its width. I can't really solve this because there's too many variables in it. So we need to really make sure that we narrow it down to one variable. So we know that the length is equal to 5 feet more than, so 5 added to the width. Once we've done that and recognize that the length, we can write it in terms of the width, we can replace that in our original equation. So instead of A equals L times W, we can write A is equal to W, the width, times the length, which we can replace by our new expression here. So this is replacing L. W plus 5 is replacing L up here. Now we can write our function rule from this equation, and we can say the function rule A is equal to W times W plus 5, or A is equal to W squared plus 5W, since we've distributed that W outside, represents the rectangle's area. Now we have our function rule, we can figure out the answer to the question. It says, well, what happens if the width is 9 feet? Now we need to find the actual area. So we'll substitute 9 for W in our function rule, and then using the order of operations, we figure out that the area is 126 feet squared. Here are some sample problems. A landfill has 50,000 tons of waste in it. Each month it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after m months? So first what we need to do is find our relationship. within the problem. So the landfill, so the amount of waste it has, okay, is 50,000 tons, and accumulates an average of 420 more tons per month. Okay, so the amount of waste, let's define our variables. Let W equal amount of waste in tons, and M equal the number of months. So really we're saying W is equal to the amount of waste in tons is equal to the 50,000 that it started with plus 420 per month, which means we're multiplying by N. Now usually we write an equation with any terms with variables in it first, then the constants. Even though these two are exactly the same thing, we generally write any terms with variables before any terms that are constants. So by commutative property, we just switch these two around and change it to 420 times M plus 50,000. In problem 2, we have write a function rule for the area of a triangle whose height is 4 inches more than twice the length of its base. What is the area of the triangle when the length of its base is 16 inches? So this again is a two-part problem. First we need to write the function rule, then we need to actually find the area of the triangle when the length of the base is 16. So well, let's start off with what we know. We know that the area of a triangle is 1/2 times the base times the height. But I have two variables here, base and height. So even if I know the base, I can't really solve this formula because I don't know the height. So I need to define some variables. What do we know about the height? Well, we know the height is 4 inches more than twice the length of its base. So let's think about what that says. Okay, so the area of the measure of the height, so let H represent the height, equals 4 more than twice the length of the base. So if I have my base and I multiply it by 2, and then I add 4 to it, that should equal the height of the triangle. Now we can substitute that in for the H in our original equation. So we can have A equals 1/2 times our base times our height, which we will now substitute 2B plus 4. Well, let's distribute the B to each term here. So we'll have 1/2 times 2B squared plus 4B. I can still distribute that 1/2, so I can get A equals 1/2 times 2 is 1, so that just leaves me with B squared plus 1/2 times 4 is 2, so 2B. That will be my function rule. I'm still not done yet because I need to figure out the second part of the problem. It says find the area of the actual triangle if my base is 16 inches. Well, let's use the formula that we came up with. A equals base squared plus twice the base. Since I know that the base is 16 for this particular triangle, I will do 16 squared. Let's substitute that in, and then 2 times 16. 16 squared is 256 plus 2 times 16 is 32. So I will get 288 inches squared. Please do not forget to label your answers.